Really wish I'd recorded all that stuff about how to set up for the exam. Okay, so thionyl chloride. If we want to take our carboxylic acid and turn it into an anhydride, what can we use?
Would you
An
react
acid
with like
anhydride?
yeah, or a acyl chloride and then like pyridine?
Yeah, so there are several different ways that we could do this. So we already have one oxygen, so you could think of it that way. You could think of it as this is coming from the carboxylic acid. So this part would be coming from an acyl chloride. Um, so you could do that with pyridine. That's one way. What else could we do? This is a symmetrical anhydride.
An acid anhydride with a base workup, like sodium hydroxide.
Um, no, so this group is the acid anhydride. Do you mean like a carboxylate?
Oh,
Or,
I guess I meant the same exact thing she has, so never mind.
okay. um, so we could heat it up, right? So if we, since it's symmetrical, if we took this and heated it up to a really high temperature, we could dehydrate it. It would do a condensation reaction. So those are two options, and you can go through your notes and pick out more. There are plenty of ways to do it. And then our next one, going to an amide.
Could you react with like azanide and then I don't know if it would be water or aqueous acid?
Well, no. So if you reacted with azanide, um, that's a really strong base. So it would just deprotonate our acid. You could react with the amine and heat it up to a really high temperature. That's not what we really learned though, because it is pretty difficult to get that reaction to occur. Instead, typically it's better to go through the acyl chloride. So a much easier reaction would be to go through the acyl chloride and then add in the amine that this would be made from. And then you would want to add an excess, at least 2 equivalents of the amine, so that you can deprotonate your intermediate. So remember, once we add on 1 equivalent of the amine, we're going to have the protonated form, and we would want to deprotonate it. So this is the probably better way. Any
So
questions?
I have it in my notes to just use the secondary amine and then apply heat to the reaction. Would that work?
Yeah, it probably would work. Your book talked about it. In class, I mostly talked about doing it this way. Because yeah, you can do the condensation without having to go through the acyl chloride. It's just your yield is going to be a lot lower. Okay, so we're gonna move forward here and let's see what we end up with. Oh, sorry, I see a request to go back. Were there any questions about this page, or did we just want to go back just to see it? Okay. Okay, so this next one, sorry, I have no idea why I put LDA in here. I'm gonna cross that out. So this will be 2 and 3. So I'm gonna go ahead and put you into breakout rooms, and I'm gonna give you about 2 minutes to work on this. I'm gonna put you into pretty large breakout rooms. I'm gonna make 6 rooms. That's gonna be about 10 to 11 people. Would you guys rather have 2 problems to work on than 1? Okay, so that seems to be a yes. So go ahead and copy this one down real fast, and then I'll go to the next page. Okay. Oh, look, this is gonna be 3. That's good. The first one is simple. You guys will get it. So I'm gonna go ahead and open up the breakout rooms. So when you have these 2 written down, you can hop on into your room. Okay, guys. So, hey, where'd it go? Sorry, having technical difficulties over here. Here we go. Okay. So on this one, I definitely heard a lot of confusion as I visited the breakout rooms. I'm not going to lecture you guys. You know what you need to be doing in order to catch yourself up on this. But I want to remind you that a really, really good way to approach this is to just make a flashcard where one side says secondary amine plus ketone and acid, and the other one says ketone to enamine. So that you have to come up with, secondary amine and acid, right? Try and learn these in a really broad sense so that when you look at your molecules, you don't have to think about anything else that's on there. You just look for the functional groups, and then it really does simplify things. There was a lot of confusion on that step in the breakout rooms that I was able to visit. Yeah, I know the demons still exist. I haven't, I'm still using my tablet. So next week, the demons should be fully exercised. Okay, so in step 1, we are creating an enamine. So this is what happens when you react a secondary amine with a ketone. You end up with an enamine. And this is really important because an enamine looks a whole lot like an enolate. So remember, you can draw an enolate like this. They both have a lone pair, and you can push out these electrons. Or you can look at them like in their resonance form. All right, so they both have very similar reactivity. And this sign here is your sign that we're going to use the enamine like this. Let me go through and erase all that real fast. So in step 2, when that alkyl halide is added, we are treating this like an enamine, or sorry, like an enolate type reaction. And we're kicking out the bromine. So in step 2, we now have an iminium ion. And then the other thing that I saw a lot of is people losing carbons. So remember, there's 1, 2, 3 carbons here. 1, 2, 3. We made a bond from our 3rd carbon to this carbon here. So that's this carbon. And then the ring came off of that one. So just make sure that you're keeping track of your carbons. I saw a lot of connection from here to here in the groups that I visited. So that's our product after step 2. And then what happens in step 3 when you take in imine, an enamine, or an iminium ion and you put it in H3O+, what happens to it?
Do you deprotonate?
Replaces with carbon.
What functional group do we end up with? Yeah, Isaiah got it in the chat. So this is just the hydrolysis of the aminium. It goes back to the ketone. So the enamine is just something that we're going through in order to add this on. If this looks like a totally alien thing to you, the thing that you want to look up is the stork enamine synthesis. Okay, so we gotta move on because we're definitely running out of time here. What's happening in this top reaction?
The chlorine is going to be removed.
So what's the overall reaction here? What category does this fall under?
This NAS
Yep.
elimination?
Yes, so this is a nucleophilic aromatic substitution, and you're right, it's going to be an elimination addition. So remember, the elimination addition means that we're going to pull off this proton first. And we create benzene. And then the amine adds, or the ammonia adds. Where does it add? Does it add in the ortho position or does it add in the meta position?
Meta.
Yeah, it's going to add in the meta position. So even though our original substitution was ortho, it's actually more stable for it to attack in the meta position. Let me erase those other arrows. That's kind of obnoxious. Because the resulting anion is going to be more stable.
Is it because of the stereo hindrance, or is it just more stable that way?
It's the stability of the anion that's being taken into consideration here.
Does it always attach in the meta position?
In this type of situation, yes, that's a safe bet. When you're doing the elimination addition, the meta product is going to be the major product.
Well, it's not only that, it's because these are electron withdrawing groups, correct? And they're deactivating?
Well, it's not so much about the deactivation. It's because they're electron withdrawing. This is the more stable anion than if we had added in the ortho position. Sorry, let me doodle that out real fast. So if we had added into the ortho position, this anion is less stable. If you were to do the resonance forms of this, you would end up with some really unfavorable situations. Okay. So this is not our final product, obviously. We have a negative charge on the benzene ring. We have a positive charge on the amine. Basically, we're going to have some proton transfer action here. We have an excess of ammonia that's going to help us deprotonate here and reprotonate here. So our final product will be an aniline derivative. So the key thing here is to know to create the meta and not the ortho product. And that's, oh, I don't know why I started erasing that because it's in the way. I'm going to erase this. Okay. This next one, we have some interesting stuff happening. I think this was really distracting to a lot of people. This is from the notes. This is just how we do the substitution with sodium hydroxide a lot of the times, creating a more basic environment using aqueous sodium bicarbonate just helps the reaction move more quickly. So we're still just considering this situation though. This is going to be a nucleophilic aromatic substitution addition elimination, so it's the opposite. and you're welcome to go through your notes and take a look at that mechanism. After step 1, we are going to have this. And then we react with Jones reagent. What's going to happen?
Will it make a?
An oxidation of the alcohol, or no?
It would turn the alcohol group into a carbonyl, right?
No, so I'm looking for a side chain reaction here.
It would turn that into a carboxylic acid.
Carboxylic acid.
Right. Yeah, I wish I hadn't put the phenol on there. I think that's misleading. That wasn't what I was looking for. I'll try not to do that on the exam. So remember, the key thing here is that the side chain, when it's oxidized, you actually lose whatever excess carbons you have, and the oxidation occurs only in the benzoic position. So no matter what, you end up with a benzoic acid derivative. And then in step 3, we're adding in an excess of phenol and sulfuric acid. What am I asking you to do here?
A Fischer esterification, or yeah, Fischer
Yeah.
esterification.
Yep, you got it. Oh, I'm gonna run out of space. I'm gonna erase step 1 just so I have a little more space here. So we still have all this stuff on here. We still have our carbonyl, but now instead of a carboxylic acid, we have an ester. So that covered quite a lot of material there. And yeah, in the future, I won't put Jones reagent with anything that has phenol on it because that is confusing. That wasn't what I was looking for.
Yeah, so that is my only confusion, is that because of that benzoic position, that alcohol group just won't be reacted with at all.
No, there probably would have been a reaction. I'm not sure that it's possible with the nitro groups on there, but usually when you react phenol, sorry, this is completely unrelated, with Jones, you actually end up making what's called benzoquinone. And this is not something that we covered, so I won't put that on there. And I don't think that's possible with the nitro groups on there. So yeah, that was my bad. I shouldn't have put I was trying to combine several ideas to get you guys used to what you'll see on the exam. And that ended up just being messy, so I apologize. Okay, so I did not give you time to work on this in a group. It's 10:47. I think we can actually crank through this one pretty quickly. It's not very difficult. It just looks like it is. So let's do this one, and then this will be our last one of the day. So in step 1, what is that?
You're adding on that
Friedel
everything attached to the chloride.
acylation?
Right, yes, this is a Friedel-Crafts acylation. So basically replace this with the benzene, right? We don't have to worry about any rearrangements or anything with acylation. What is happening in step 2?
Is it a Wolff-Kishner reduction?
Yes, perfect. And what happens in a Wolff-Kishner reduction?
Gets rid of the carbonyl.
Yep. Nice. Okay, and then in step 3, we're adding in N-bromosuccinimide and light.
Are we adding the bromine on the benzyl position?
Exactly, yeah. So this is a aromatic side chain reaction, which will be covered on the exam. So we are going to put a bromine in the benzylic position. And then we add in sodium cyanide. What's going to happen?
The bromine leaves and the cyanide attaches.
Right, what type of reaction is this? Actually, I'm going to draw this lower so that we can do a mechanism if we need to. What type of reaction is this?
SN2.
Yep. You're definitely going to see a lot of stuff like that from here on out because we are doing chemistry with nitriles. They are a carboxylic acid derivative. What happens when you react a nitrile with a Grignard?
Is it creation of a ketone?
Yeah, so this creates a ketone. After step 5, you haven't quite made it to the ketone, but once you do the hydrolysis, you'll have it. So after step 5, you have, here's your carbon from your nitrile. You have a pretty crazy situation here. And then you have your other carbons. And then you hydrolyze it. So the key thing here is keeping track of your carbons. So remember to count this one. So here is your nitrile carbon. Here are the 3 carbons from the Grignard. And here's your ketone. Okay, any questions on this one?
What was
That
the
only took
part
us
3
3 minutes.
reaction called?
I'm sorry, what?
What was the reaction in part 3 called?
Oh, that's just a bromination in the benzylic position. So you could probably find it under benzylic halogenation. And that reaction was done with N-bromo succinimide. Okay, so we are out of time. On Monday, we're going to pick back up with these problems. Today, I'm going to add a couple more to this slideshow just to cover some of the later material. And on Monday, we're just going to go. So you need to work on these over the weekend. You need to get a head start on them. Otherwise, it's just going to be you watching me talk you through things, and you're not going to get the experience of trying it yourself, figuring out what you don't know, and then getting to see like the correct path. So that's really, really important to this type of thing. If you just show up and watch me work through problems, you're not going to get anything from that. So make sure that you put some effort in on these over the weekend. Plus, you should be studying anyway, right? And these are problems written by me. The exam is written by me, so they're going to be pretty similar. I do think the ones that I put in this review are more challenging than what I would put on the exam, but I think that's better for the review to be a bit more challenging. Stuart, is your question for Anne?
I know she said something about maybe Sunday if she gets back from her flight in time, but she said maybe Monday she'll do one.
Okay. Cool. So I will find out from her and make sure that you guys have that information. I do have office hours on Monday and Tuesday. There will not be office hours on Wednesday because I'll be proctoring an exam. I'll be proctoring your exam during those office hours. So Monday and Tuesday, if you want to come to office hours, that would be really fun. Okay. Have a good weekend, guys. Get some sleep, please.
Are these questions that we're doing right now more of an accurate review than the questions that are asked up that are already on Canvas?
You mean like the practice exam?
Yes.
Yeah, so those practice exams were old exams that Dr. Allison gave. So those are from test banks. I don't really like the way that they ask the questions.
Yeah.
I usually use those because I would normally give the ACS final exam, but you guys are not
Right.
taking the ACS final. So I would expect your test questions to look more like the ones that you've been seeing on your quizzes, because those are written by
Okay.
me and your exam is written by me.
Okay.
The practice problems that we're doing in class, I mostly hit on reactions and try to get you guys through some mechanisms.
Mhm.
There will be some conceptual questions, some essay questions like on the first one.
Okay.
Matthew, I see your question about the attendance code. Where did that go? Sorry, hold on. It's under my bar at the bottom of my screen. Oh, come on. Okay, it's 5223. Okay, are there any questions?